we know there are three physical parameters that define the characteristics of gases: volume, pressure, and temperature. Now let's see if there is any relationship between these three physical parameters. Recall, as the temperature increases, that is, as the heat energy of the particles increases, the kinetic energy of the particles increases, and so the speed of the particles increase. So over here we have a container. We have two gas molecules. The temperature is maintained at 27 degrees Celsius or 300 Kelvin. So now let's observe what happens. So the molecules are colliding with the walls of the container. So in 9 seconds, there are 9 hits. That is, there is 1 hit per second. Now, if the temperature is increased to 327 degrees Celsius, which is 600 Kelvin, that is, the temperature is made double. Initially, we had 300 Kelvin. Now we have 600 Kelvin. When the temperature is doubled, if we observe, so on heating, the temperature was doubled. So you observe that you get 18 hits. So as these are colliding, so in 9 seconds, that is the time remaining the same, in 9 seconds you got 18 hits. So if we have 18 hits per 9 seconds, this means 2 hits per second. So initially at 300 Kelvin, we got 1 hit per second. At 600 Kelvin, we are getting 2 hits per second. So let's compare again. So when the temperature was 300 Kelvin, we got 9 hits in 9 seconds. That means we got 1 hit in 1 second. So 1 hit per second. When the temperature was doubled, by heating it, the temperature was doubled. So we have 600 Kelvin. As the temperature was doubled, the number of hits per second also doubled. So from 1 hit per second, now we have 18 hits per 9 seconds, which means 2 hits per second. So as the temperature doubles, the number of hits per time also doubles. So as temperature increases, the pressure increases. Why is that so? This is because if this is the space or the volume in which the molecules are enclosed, we know they are in a state of constant motion, so they collide with one another and with the walls of the container. As temperature increases, the kinetic energy of the particles increases. As the kinetic energy increases, the speed increases. As the speed of the particles increase, the number of hits per unit time on the walls of the container increases. And we know number of hits per time is the pressure. So as the number of hits per time increases, the pressure increases. So that is why when we increase the temperature, the number of hits per unit time increase, and so the pressure increases. Let's recall what happens when we increase the temperature. As the temperature increases, the kinetic energy of the particles increases. As the kinetic energy increases, the speed of the particles increase. So as the speed of the particles increase, the number of hits per unit time also increases, and this is the pressure. So the pressure of gas increases with the increase in temperature. Similarly, vice versa, if we decrease the temperature, that is, as the temperature decreases, the kinetic energy of the particles decreases. So the speed of the particles decreases. As the speed of the particles decreases, the number of hits per unit time also decreases, and so the pressure of the gas particles decreases. So with the decrease in temperature, there is a decrease in the pressure of the gas. So the pressure of a gas increases with the increase of temperature. Is it true or false? So we know as we increase the temperature, the kinetic energy of the particles increase, the speed of the particles increases, the number of hits per unit time increases, and so the pressure increases. So with the increase in the temperature, or the vice versa case, with the increase in pressure, the temperature increases. So with the increase in temperature, pressure increases, and if the pressure increases, the temperature increases. Now let's observe another case. So this is the volume in which the gas molecules are enclosed. So as they are in a state of constant motion, In 9 seconds, we get 9 hits. That means 1 hit per second. Now, if the volume of the container is reduced to half, so you observe that in 9 seconds again, there are 18 hits. So as the volume of the container is reduced to half, the number of hits per second increases or doubles. So initially we had a volume, so we got 1 hit per second. Now when we reduced the volume of the container to half, we got 18 hits in 9 seconds. That means we got 2 hits per second. So on reducing the volume of the container to half, the number of hits per second doubles. Let's compare this again. So we initially had this volume in which the molecules were enclosed. So we got 1 hit per second. That is, in 9 seconds, we got 9 hits. Now, if the volume is reduced to half, so initially we had 1 hit per second. When the volume is reduced to half, we get 18 hits in 9 seconds. This means we get 2 hits per second. So when the volume is reduced to half, the number of hits per second doubles. So we see that as the volume decreases, the pressure increases. Now, why is that so? This is because initially if the molecules are enclosed in this volume, so now as we decrease the volume, since the molecules are moving at the same speed, now they have lesser distance to cover. That is, the space has reduced. So they collide with the walls of the container more. As they collide more, the number of hits per unit time increases, and so the pressure increases. Let's recall what happens. As the volume of the container decreases, there is less space for the same number of particles. And since the particles are moving with the same speed, so the number of hits per unit time increases. Since now the space has decreased, so now the particles collide with the walls more, and so the pressure of the particles increases. So as the volume decreases, the pressure increases. Similarly, we have the vice versa case. If we increase the volume of the container, what happens? There is more space for the same number of particles. So now the speed of the particles remains the same and they have a greater distance to cover. This means that number of hits per unit time will decrease, and as this decreases, the pressure decreases. So as the volume increases, the pressure decreases. Let's observe what happens here. So in physics, you must have studied that pressure always is at equilibrium. So the outside pressure should be equal to the inside pressure. Let's observe. So there's a block of wood. At this state, we see that equilibrium is maintained. Since the lid is stationary, the molecules are moving inside the space. Now if we increase the external pressure by putting one more block of wood, what happens? The external pressure increases, the internal pressure has to increase. And this is possible only when they have lesser space to travel. So as the volume decreases, they hit the walls of the container more. So as external pressure increases, the internal pressure increases. So now if we remove the extra block of wood, the external pressure decreases. To balance it, the internal pressure has to decrease. This means the number of hits per unit time has to decrease. And this is possible only when the volume increases. As the volume will increase, there will be more space for the particles to travel. So the number of hits per unit time will decrease, and so the pressure decreases. This means with the increase in pressure, volume decreases. With the decrease in pressure, volume increases. Let's recall. So as the outside pressure increases, the inside pressure has to increase. This means the number of hits per unit time has to increase. And since the number of particles remains constant, the volume decreases. This means that since the number of hits has to increase, if the particles will have a lesser space to travel, they will collide with the walls more. So the number of hits per unit time will increase as the volume decreases. So as pressure increases, volume decreases. Similarly, we have the vice versa case. If the outside pressure decreases, to balance it, the inside pressure has to decrease. This means the number of hits per unit time has to decrease. And how is this possible? This is possible only if the volume of the container increases. If the volume increases, the number of hits per unit time will decrease, because now the number of particles remaining the same, they have more space to cover. So if they have a greater volume, the number of hits per unit time decreases. So as pressure decreases, the volume increases. So we have seen so far that as temperature increases, pressure increases. As temperature decreases, pressure decreases. This is a vice versa case. As pressure increases, temperature increases. Similarly, if pressure decreases, temperature decreases. Also, we have seen the relationship between volume and pressure. If the volume increases, pressure decreases. Or if the volume decreases, pressure increases. Similarly, if the pressure decreases, volume increases. And as pressure increases, volume decreases. So these are the relationships between the three physical parameters of gases. That is pressure, volume and temperature.